Okay, it's working. So let's continue with systems of inequalities. So last section of chapter 5, systems of inequalities. Systems of inequalities, linear or not, we're going to look at all of them, linear and nonlinear. When we solve systems of inequalities in two variables, all we need to do is graph the inequalities. Because we're not going to have solutions like 2, 2, or maybe 3, 2, and 3, -2, and -3. No, this is a totally different story. When we solve systems of inequalities, we will have to find the areas on the coordinate system where the system has solutions. And we will not be able to name them. We're going to say they're found here, or they're found here, or they're found here, but you're not going to be able to name them, all of them. You can name some, but not all. Okay, so let's start. I'm sure you've seen this before in the previous classes. So we're going to look at linear systems of inequalities, and then we're going to look at nonlinear. On page 600, let's start with 30. And we have a system of 2x minus y less than or equal to 4, and 3x plus 2y greater than -6. Okay. Now let's establish that this is, first of all, it's a system of inequalities. They're not equations. Would you agree? And both of them are linear. There is no x squared, and there is no xy, there is no division by x or anything, right? They're both linear. Good. So here are the steps towards solving the system of linear inequalities. Step number 1. I write never. That will never work. It's totally different method. So first of all, I write the corresponding equation. And you can say, wait a minute, you have the inequality symbol, now you wrote the equal symbol. True, I'm not changing anything. I need to write the equation so I can graph it. So first I write the corresponding equation for the first inequality. And in step number 2, I graph it. Graph 2x minus y equals 4. No difficulty here because it's linear. So I need to find when x is 0, how much is y? Excellent. So 0, -4. And then I want to find when y is 0, how much is x? 2. So then 2, 0. So let's go back for a moment. I did start this, I know that, but okay. So for now, we looked at the first inequality and we said, okay, let's write the corresponding equation. And now let's graph this equation. I found the ordered pairs. So now I'm ready to plot and extend the line and graph the line. So 0, -4 is this point. And 2, 0 is this point. So now, before I graph, I have to look at the inequality symbol and see if it has the equal symbol. If it has the equal symbol, then when I graph, it's going to be a solid line, not a dashed line. So it's a solid line. I missed it. On the line, below the line, left of the line, right of the line, you choose. Please write 2x minus y equals 4. We did not graph the inequality yet. We only graphed the equation.
Wait till after that's being shaded.
Right, exactly. So right now, but the shading is done when we're done with each equation,
Yes.
not at the very end. Perfect. So in number 3, step number 3, we graph 2x minus y less than or equal to 4, bless you, choosing a point to check. I always choose 0, 0 unless the graph goes through the origin. If it goes through the origin, I cannot use the origin. So here's how we think next. We say this. This line divides the entire plane into two regions. The region below it, let's say, and the region above it. So now I see that the origin is on this side. So I'm really checking this territory. I plug it in. This is all 0. 0 less than or equal to 4. If you say that this is true, then I will shade in this area. If you say, no, 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 it's not true, it's false, then I will have to shade in this area. So is it true? It's true. Because it's true, I will shade in the area that contains the point that I used to get a true statement. Now, all this thing that you see, everything here, including the line, this is 2x minus y less than or equal to 4. The entire region, not just the line. The line is the equation. The entire region consists of solutions to 2x minus y less than or equal to 4. Can I name them? No. I can give you a couple. I can say 0, 0. I can say 0, 2. I can say negative 10, 0. I can say negative 10, 10. I can say negative 12, negative 12. But I cannot give them all to you. There is no way. So the only way I can present the solution is by graphing it. Okay, we repeat the steps for 3x plus 2y greater than negative 6. Now, in case you're asking, fine, this is a fantastic method. What is it used for? I will have to say for the next section. But my colleagues decided to remove that from the course. I asked them, I said, why am I doing this if I can show applications of it? It's required. Okay, fine. So, this is a very interesting method. And the method is called linear programming, in which we use this, and in other methods. But okay. So, we continue with 3x plus 2y equals negative 6. We write the equation. When x is 0, how much is y? Very good. Negative 3. So then 0 comma negative 3. Now, when y is 0? Negative 2. So negative 2, 0. Do we agree with the points? Yes? Everyone? Okay, so let's plot those on the same coordinate system. It's mandatory. It has to be on the same. 0, negative 3 is this point. And negative 2, 0 is this point. I cannot graph the line before I look here. If this contains the equal symbol, I'll graph it as a solid line. Since it does not, it cannot be graphed as a solid line. Because points on it will not be part of the solution. That's why. So please write 3x plus 2y equals negative 6. We did not graph the inequality. We only graphed the equation. For the same reason as before, we realize that this line divides the entire plane into two regions, to the right and to the left. It does not pass through the origin, so I will use the origin, checking this area. So with 0, 0, I get that 0 is greater than negative 6. If you say true, I will shade in this area. If you say false, I will shade in the opposite. Do you say true or you say false? It's true, right? 0 is greater than negative 6. Yes, that's okay. Okay, so this entire area is 3x plus 2y greater than negative 6. Now, remember, these are two conditions that have to be fulfilled at the same time. This is like common domain, sort of. What do you think I'm going to do next? Right. It's where both are present. So this is a solution to the first. This is a solution to the second, but I want both. Meaning all points on this line, not points on this line, but getting very, very close, and everything else. And this is both. So in other words, if I want to find ordered pairs that verify both inequalities at the same time, I have to pick them from the orange territory. Not from the purple, or whatever, blue, not from the blue, not from the green, but specifically from the orange. I cannot pick points on this line either, but I can pick points on this line. So those points are part of the solution. These points are not part of the solution. Any questions? So this was a linear system. It's linear.
So when you solve these, you don't give a.
Well, you can give a solution. You can only show the graph.
Okay, so that's what the final answer is.
That's the final answer. There is no way. How will I explain? I'm going to say to the left of this line and to the right of that line. You can picture that, right? No, we can't. So that's the only way. We don't have another method. Okay. So let's look at nonlinear now. This was a linear. Now let's look at nonlinear. Let's say 48. X squared plus y squared less than or equal to 4. And x plus y greater than 1. The reason why, just to make sure I mentioned that, the reason why I wanted to look at 5.4 and 5.5 and not, I'm not skipping anything, but I didn't want to interrupt the chapter 5 for this, because this is different. It has the same basic idea of solving systems, the same idea, but it's going to look very different. So that's why I wanted to finish chapter 5, and then we'll work on 6.1 and then 8.1. And then we'll start reviewing for test 3 and the final.
Is that what the last page of the test review is about? What's on 6.1?
No, both 6.1 and 8.1. The sequences and Gauss-Jordan. Okay, very good. So we start like before, nothing different. X squared plus y squared equals 4. But again, I have to dig deep and ask myself, what is it? And how do I graph it? There's no parabola with x squared and y squared at the same time. Chapter 2. I tortured you with it? Plenty.
Yes, you didn't torture me, though. I was having too much fun. So,
That's why we need to review. And that's why I need to review a lot. So we don't forget these things. So what is it?
it's exponential function.
I don't know. Is it? It's a circle. It's a circle with a center at and the radius at of. Center? The radius is 2. And the center is? Center of 1, 1 will look like this. This would be a center of 1, 1. Yes. Very good. Let's graph it. Awesome. You understand why we need to review?
Yes.
Thank you. Well, we forget. I mean, it's nothing wrong. But yes, it's a lot of material. That's why we need to review it. If we want to remember anything, good. But now I don't know. I have to look here. Solid or not? Yes. This circle is x squared plus y squared equals 4. It's not the inequality. And now I have to solve the inequality. Okay. I see that this circle divides the entire plane into 2 regions, the inside of the circle and the outside of the circle. I will use 0, 0 for the inside of the circle. If it works, I'll shade it in. If it doesn't, I'll shade the outside. So with 0, 0, 0 less than or equal to 4, if you say true, I'll shade in the inside. If you say false, I'll shade in the outside. Yes, it's true. This, everything inside and the points on the circumference represent solutions to this. Not the circumference. The circumference is just the equation. The circumference and the inside are solutions to this. Okay, now I have x plus y equals 1. X plus y equals 1. When x is 0, thank you. When y is 0, x is 1, so 1 comma 0. Perfect. I will plot those two. 1, 0, 0, 1. Perfect. But now I have to look. I can't just draw. It's a line, I know that, but this will tell me whether it's going to be solid or not. So it cannot be solid, very good. So it will be this. On the line, please, x plus y equals 1. So now, the line, forget about the circle, we don't care. The line divides the entire plane into two regions, this and this. Since it does not pass through the origin, I will use the origin checking this area. Okay, 0 greater than 1. If you say true, I will shade in this. If you say false, I will shade in this. False indeed, so that's false. This orange territory is x plus y greater than 1. But I'm interested in the system. I'm not interested in the green territory. I'm not interested in the orange territory. I'm interested in points where that I could, or the pairs that I could pick to solve the system. Do they overlap? Yes, they do. So it's points on the curve, which is the circle, points very, very close to this line, not points on that line, and this. So this, it consists of, that area has the solutions of the system. $56. Any questions on this one? They're more visual and kind of interesting, maybe? Fun. Excellent. That's all I want. If I entertain you, I met my target. 56. X squared plus y squared less than or equal to 16, and y less than 2 to the x. Because now we know so much, we can make combos. Okay, the first one, after we write the equation, what is it? It's a circle, centered at 0, 0 at the origin, with a radius of 4. Excellent. So the equation, I have to write it. I have to write the center is still 0, 0, and this time the radius is 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. You know it's not going to be perfect. Sorry about that. So this is x squared plus y squared equals 16. I forgot to ask, but I already looked. It has the equal symbol, so that's why it's solid. When I plug in 0, which I'm checking the inside with this point, I get 0 less than or equal to 16. If it's true, I shade it in. If it's false, I shade in the outside. It's true. So this inside, everything including the circumference, x squared plus y squared less than or equal to 16. So I'm done with the first one. And now I have to look at the second one, which is y equals 2 to the x. Well, I don't have to dig too deep because this is chapter 4. What kind of function is it? How do I graph it?
Exponential.
It's exponential. Is it increasing on all its domain or decreasing on all its domain? Very good. It's because the base is greater than 1. It always crosses at 0, 1. Sorry. Okay, do I graph it as a solid?
Yeah.
No, okay. Sorry about that. I forgot to ask. Easy fix. I don't know what I would do without whiteout. Good. So now this is 2 to the x, y equals 2 to the x. This is not the inequality. But I see that even this graph divides the region into upper and lower. Since the lower has 0, 0, keeping in mind 0 on this side, less than 2 to 0, but 2 to 0 is 1. Is 0 less than 1? Okay, very good then. The red territory is y less than 2 to the x. So what do I do now with these two territories? I have to intersect. So this purple, whatever that color is, and the orange or something else, whatever, all points on the curve, on the circumference, not points on 2 to the x, but everything else, both. That's where we find the solutions. I just want to show one with a graph that passes through the origin, and then we can stop. Just one more. Is that okay?
Yeah.
Any questions on this problem? They're kind of common sense. You feel okay about this one? Okay. So let's look at one more. On the same page, 54. X squared plus y squared less than 4. And y minus x squared greater than or equal to 0. Okay. So first, the first one, we have no secrets there. We know that it's 4. So then the center is 0, 0, and the radius is 2. And it's not a solid curve. We agree so far. So let's graph it. 2, 2, 2, and 2. Not a solid curve. Still, this is x squared plus y squared equals 4. We plug in 0, 0, we get 0 less than 4. It's true, so this will be the inside. Everything, not the points on the line, on the curve. But all this inside is indeed x squared plus y squared equals 4. Of course, less than 4. Now let's graph y minus x squared equals 0. So what am I graphing, really? I'm graphing y equals x squared. So then what do I graph here? What is this? We graphed it like millions of times already. With the vertex at the, of course. Solid or not? Good. So it passes through 1, 1, negative 1, 1. So here's the graph. I missed it. So this is the graph of y equals x squared. It divides the entire region into two pieces. This piece, the inside, and the outside. However, I cannot use 0, 0. It passes through the origin. No problem. I'm going to pick this point, 0, 10. So I'm checking the inside with 0 and 10. 0 for x, 10 for y. 10, 0. So is 10 greater than or equal to 0? It is. So then I will shade in the inside. So therefore, now I have to find the common territory, or the common domain if you want. So it's points on this, very, very close, but not including. So this is both. So if